Taking question number 17 of exercise 7.9 from the chapter integrals. Friends, the question is like this. We have to evaluate this definite integral. It is integration of sec square 2 sec square x plus x cube plus 2 with respect to x from the limit 0 to pi by 4. It's a simple question, and to solve this question we assume that the given definite integral is equal to I and fx is equal to the same integral but without limits. Now we can integrate fx and write this as equal to 2 10x because integration of sec square x is 10x. Integration of x cube would be x to the power of 4 upon 4 and integration of 2 would be equal to 2x. Therefore, by the second fundamental theorem of integral calculus, I can write I as equal to f of pi by 4 minus f of 0. So the value of this definite integral would be given by the difference of f of pi by 4 minus f of 0. So f of pi by 4 is obtained by placing x is equal to pi by 4 in the complete expression, and f of 0 would be obtained by placing x as equal to 0 in this complete expression. And when we place x is equal to 0, all these three terms would be equal to 0, and f of pi by 4 would be equal to 2 10 of pi by 4 plus pi by 4 whole to the power of 4 upon 4 plus 2 into pi by 4. Okay, and this would give me 2 into pi to the power of 4 upon 256 into 4 plus pi by 2. Further, we can write instead of 256 into 4 1024 to obtain the final answer. Okay, now we are going to move to question number 18. Now the question is, we have to evaluate this definite integral, integration of sine square x upon 2 minus cos square x by 2 with respect to x from the limit 0 to pi. Okay, now to solve this question, first of all I assume the given integral as equal to I and fx the same integral without limits. Okay, now using this result that cos square a minus sine square a is equal to cos 2a. Okay, so I can write this term as equal to minus cos x. Okay, so for this I have written minus cos x because you can see that if we take minus sign common from both these terms, okay, then only they will be in the form of cos square x by 2 minus sine square x by 2. Okay, and in this form only the formula would be applicable, and so we are going to get this value as equal to minus cos x. Therefore fx is equal to integration is equal to minus times integration of cos x with respect to x. Okay, now we can easily integrate cos x as equal to sin x, so this integral is equal to minus sin x, and by the second fundamental theorem of integral calculus I can write I as equal to f of pi minus f of 0. So this is equal to minus sin pi minus sin of 0. Sin of pi is equal to 0, sin of 0 is equal to 0, so which gives me the required answer. Now taking question number 19 of exercise 7.9, we have to evaluate this definite integral, integration of 6x plus 3 upon x square plus 4 dx from the limit 0 to 2. Now to solve this question, first of all we assume that the given definite integral as equal to I and fx as equal to the same integral without limits. Okay, we cannot solve this integral directly, so for this what I do, for simplification I have converted this integral as the sum of these two integrals. Okay, now this can be integrated directly, but again this cannot be integrated directly. It can be solved by only by applying the substitution method only. So I can write that integration of x upon x square plus 4 dx, I take this integral and I substitute x square plus 4 as equal to t, so I get 2x dx as equal to dt. For x dx I can write dt upon 2, so for x dx I have written dt upon 2, and for x square plus 2 I am going to write t, so this will be equal to 1 by 2 times log of x square plus 4. Okay, and I can write this value of fx as equal to, so this 6 as it is, and 1 by 2 times log of x square plus 4 to obtain 6 upon 2 log of x square plus 4. And for this term, integration of 1 upon x square plus 4 dx, I'm going to write this as equal to 1 by 2 tan inverse of x upon 2. So this gives me 3 by 2 because 3 was multiplying with the integral. Okay, so this is the value of fx, and it can be simplified and written as equal to 3 times log of x square plus 4 plus 3 by 2 times tan inverse of x upon 2. So by the second fundamental theorem of integral calculus, the value of the given integral I would be equal to f of 2 minus f of 0, and placing the value of f of 2 as equal to 3 log of 2 square plus 4 plus 3 by 2 tan inverse of 2 upon 2, and f of 0 as equal to, here I have multiplied with minus sign also, so this will be equal to minus 3 log of 0 plus 4 minus 3 by 2 tan inverse of 0. Okay, now this would be equal to 0 because tan inverse of 0 is equal to 0. This will be equal to 3 log 4, and 2 square plus 4 is equal to 8, so I obtained 3 log 8, and tan inverse of 2 upon 2 would be equal to 3 by 2 tan inverse of 1. Okay, so these two terms can be written as 3 log of 8 upon 4. Okay, 3 taken as common, and log 8 minus log 4 would be written as log of 8 upon 4. So this is going to become 2, and this would, and the second term would be 3 pi by 8. So 3 log 2 plus 3 pi by 8 is the required answer. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.